Hey students, welcome back to lecture series on Z transform. Already I have uploaded plenty of the videos on my playlist. If you want to see this video, go and check in I button over here. You will get my entire playlist for Z transform. Okay, or you can check in my description box also. You will get the entire playlist for the Z transform, inverse Z transform, Fourier sine, cosine and their inverses, and unit first like a linear differential equation with a constant coefficient. Okay, you will get the entire playlist in my description box. So in my today's video, I'm gonna explain to you our inverse Z transform. Already we have finished entire lecture series on Z transform. So in today's video, I'm gonna explain to you all inverse Z transform. If you understand Z transform well, na guys, you don't need to learn even inverse Z transform also. Okay, so if you have this concept perfect, then you can easily solve inverse Z transform. Inverse function means, what is the inverse function? When we take mapping from domain to range, then we get the function. Okay, when we take mapping from domain to range, we get the function. And if we take its inverse mapping from range to domain, we get the its inverse function. Now see that it is not the difficult. F from x to y is the inverse function, regular function, and f from y to x. Okay, now let me write. Okay, f from x to y, it is the function. Okay, if we consider this one is the function, okay, then we write it's the inverse function f from inverse of y to x. Okay, this is the inverse function. Okay, this one is the inverse function. See that it is not that difficult. Similar concept I'm going to apply here for our inverse Z transform. Okay, so for solving the question based on the inverse Z transform, you need to be familiar with the what is the Z transform. Okay, now let me explain shortly what actually the Z transform. If you want to see entire Z transform, go and check in my playlist. Okay, yes, so let me explain what is the inverse Z transform. Okay, for that what we have Z transform of sequence, Z transform of sequence f of k. Okay, Z transform of a sequence f of k, we write this one as summation minus infinity k running from minus infinity to plus infinity. Okay, f of k z raised to minus k. Okay, this one is a Z transform of sequence f of k. Z transform of sequence f of k can be written as k running from minus infinity to plus infinity f of k z raised to minus k. Okay, this one is the actually Z transform for sequence. Okay, yes. So we denote this one as a f of z also. Okay, Z transform of f of k. So how can we write Z transform of f of k? One more way, f of k can be written as f of z. Okay, this one we used to denote, as a Z transform. Okay, so this one is the first form. Actually you need to remember. Okay, these are the very much important, guys. This one is also. Okay, that is the formula already we learned in our previous Z transform. Actually we denote this is a Z transform of f of z, as f of k as a f of z. Okay, yes. Now let me explain what actually the inverse Z transform. Okay, so now see that if you are going, we consider a z, we consider operator z as a function over here. Okay, so we are taking z mapping from f of k to f of z. Okay, we are taking z mapping from f of k to f of z, then its inverse become. So compare this one with this one, both of the definition for function, inverse function. Okay, so that means what actually it represent, this one is a Z transform from f of k to f of z. Okay, this one is a Z transform from f of k to f of z. Okay, yes, and it's a inverse transform, Z inverse. We write this one as the, take its inverse mapping like x to y, then we take y to x as inverse mapping. Okay, that means we write f of z to f of k, okay, this one is our inverse transform. Okay, and in mathematical language we write z inverse of f of z. Okay, z inverse of f of z. Now see that this f of z, it is different, okay, than small f of z. Z inverse of f of z, we write it as the f of k. Okay, this one is actually required z inverse Z transform. Okay, so when we have Z transform of f of k is f of z, then we write inverse Z transform of f of z as f of k. Okay, that you need to understand. So formulas are also similar going to replace, guys. We don't have anything difference in formulas also. Okay. Yes, so let me explain some of the formula over here for our properties. Okay, yes. So inverse Z transform also are having some of the properties like Z transform. Okay, so you need to remember this one as a Z transform. Okay, this one as the Z transform. This one as the inverse Z transform. Okay, yeah, this one is Z transform, inverse Z transform. Yes, so we know that we have the Z transform. I'm going to write a property for Z transform first. Okay, then I'm going to relate this property with the inverse Z transform so that it will be way easier for you all to remember this for a long time. Okay, yes. So we know that Z transform of a raised to k when k greater equal 0. Okay, we know that a raised to k can when k greater than 0 we write this one as a z upon z minus a and modulus of a z greater than modulus of a. Okay, see that this one is the z transform. Okay, for a raised to k. Already we learned this, guys, in our previous lecture. Okay, yes. Okay, so I want its inverse Z transform. Okay, inverse Z transform. How can we write inverse Z transform? Now we are going to take mapping from here to here now. Okay, pre-image mapping. Okay, now see that we write a Z inverse of Z upon A minus Z. Z minus A, sorry, Z minus A. We are taking Z minus A here now. Yes, Z upon Z minus A. Okay, in Z inverse transform of Z upon Z minus A can be written as a raised to k, and a k greater equal 0. Okay, now see that what we have done, nothing. We just taken the formulas from Z transform. We taken its a pre-image mapping. That is only we got the inverse Z transform. Similarly, guys, you have to replace everywhere. Yes, similar thing you have to replace everywhere. Yes, let me take some another example. Okay, so that you can understand it more easily. Okay, yes. So second property first. Okay, I don't need to go for the proof of this property. Okay, actually this is Z minus A, guys. This one is a Z minus A. I don't need to prove these properties, guys. Okay, similar type of the proof I already explained in my previous lectures. Okay, so if you want, you can go and check these videos. Okay, so you will get very easily to understand this concept. Okay, yes. So we go for another property. There are several other properties, guys, but I'm not going for each and every property. We go for only the property these are important. Okay, yes. So Z transform of a raised to k when k greater than 0 I taken here. Okay, let me take another one. Z inverse of Z upon Z minus A. Okay, Z upon Z minus A when k smaller than 0. Okay, we have two another properties now. When it is for smaller than 0, when it is for greater equal 0. Okay, yes. So we write a raised to k when k smaller than 0. A raised to k when k smaller than 0. Obviously that negative k smaller than 0 means all the negative values, and that negative values gives us the value as a minus a. Okay, raised to k when k smaller than 0. Okay, so actually why I take a negative, because we have all the value for k which is negative now. That's why I take a negative a. In actual, we have Z transform of a raised to k when k smaller than 0, Z upon Z minus a. But a raised to k, we need to represent a as a negative, okay? K as a negative. So that's why I taken this negative sign over here, okay? It is way easier to remember. Okay, let me write third property. Okay, this property need to remember. These are very useful property for inverse Z transform. Yes, Z inverse of Z inverse transform of 1 upon Z minus A, Z inverse transform of 1 upon Z minus A whenever modulus of Z, okay, modulus of Z smaller than modulus of A. Okay, modulus of Z, it is smaller than modulus of A. Okay, you can see that we want this term as a positive, so obviously you have to consider the value the way that, okay, Z upon Z minus A and modulus of Z is smaller than modulus of A. Okay, Yes, so I want its inverse transform, Z inverse transform. I'm going to write this one as a raised to k minus 1. You need to remember these formulas, guys, okay? It's not that difficult. Okay, we take k, it is a bigger than 0. Okay, so let's go for the next property, fourth property. I'm going to take fourth property over here. Okay, Z inverse of 1 upon Z minus a, 1 upon Z minus a. Okay, mod Z, modulus of Z, strictly less. Okay, guys, this one is bigger than bigger value here. Okay, yes, greater than a. Okay, and mod Z smaller than mod a. Okay, mod Z smaller than mod a. So actually sometimes we have to take the value for positive, sometimes we have to take for the negative. Okay, so now see that Z minus a, mod Z it is bigger and mod a is smaller. Obviously this value gives us the positive value. Okay, but modulus of Z it is smaller than modulus of a, that means this value obviously gives us the value negative. Okay, so in this case we write minus of a raised to k minus 1. Okay, so you need to take negative sign as we have entire term negative, k minus 1. Okay, and k greater equals 0. See that, guys, these are the important properties over here. Okay, there are several other property, but you can consider this one, these are helpful here. Okay, yes, let me write one more property. Okay, Z inverse transform of, okay, Z inverse transform of Z upon Z minus a, Z minus a bracket square. Okay, Z upon Z minus a bracket square, and when modulus of Z is bigger than modulus of a. Okay, then we write it as the sequence over k into a raised to k minus 1. Okay, and k greater equals 0. This one is a fifth property. Okay, so that you must have to remember these are the property. Actually, if you want to see what is the Z transform k raised to k, you can see that I already explained this one. So what is this property? Z transform of a raised to k. Okay, Z transform of a raised k raised to k. Okay, k into a raised to k. Z transform of k into a raised to k whenever k greater than 0. I explained this property in my last lecture, guys. A Z upon Z minus a bracket square. Okay, and modulus of Z greater than modulus of a. Okay, this one is the property, guys, I explained in my last lecture. Okay, so that property, inverse of that property, I took it over here. Okay, yes, k a raised to k minus 1. Okay, you just need to replace the value Z upon a Z minus a square. It is only the a extra here, so you can take this one to out here from here. Okay, so k as it is here, a raised to, it is extra a here, so that's why I taken a out from here. Okay, a into k raised to minus 1. Okay, yes, so that means these are the formulas, guys. These are helpful here for our inverse Z transform. I hope you all have understood these formulas. For your reference, you can note these formulas down. Okay, note it down. We're gonna use this formula for our next example solving. Okay, so we go for some examples. Okay, some examples based on the inverse Z transform. Okay, so we'll take it in our next lecture, guys. Till that we wait. Okay, so thank you everyone, thank you for my today's lecture. I hope you all have understood everything over here.